So number 18 looks like this, right? 1 over 1 plus cos plus 1 over 1 minus cos equals 2 cosecant squared x. All right, what side would I start with? Left, right? There's almost nothing to do with the right. I guess I could call it 2 over sine squared, but okay. This is what I think of, because I've been doing identities a long time, so I'm going to share some of my thoughts with you. I look at the left and I have two complicated looking fractions that become one term, right? So I have to push fractions together, merge them together. What's the only way to combine fractions? LCD, right? So the LCD, well, this is complicated. I guess I just have to think the LCD is just going to be these two multiplied together, right? It's going to be 1 plus cos times 1 minus cos. By the way, what do you recognize about these guys? They're conjugates, right? If they're difference of squares factors. Okay, so this first term then, before I can combine them, they have to show the same denominator, right? Or I'll show all my steps. So I'm going to have to multiply this guy by 1 minus cos, right? Whatever I do to bottom, I have to do to the top. Okay, same over here. This fraction will be multiplied by 1 plus cos to get my right denominator. So that's what I have to multiply the numerator by. Okay, so far so good? Everyone good with this? Now I can merge them into one denominator, right? So I have my 1 plus cos. Again, I'm going to show you every single step. So here, this would just give me 1 minus cos, right? Plus 1 plus cos. Okay, so now I'm going to clean this up a bit. 1 plus 1 makes 2, right? Minus cos plus cos, they disappear. And the 2 is great because I need a 2. Okay, well, I'm stuck with this 1 plus cos, 1 minus cos, but what's the beauty of multiplying by conjugates? I get my difference of squares, right? And I get my Pythagorean. Isn't that going to be 1 minus cos squared? Okay, what's 1 minus cos squared? What's sine squared when we move him up top? The reciprocal, he moves up to the top and becomes cosecant. Isn't that what you were looking for? How many people got this far? Did you get all the way? Did you get all the way to the end? Good. Yeah, good. Remember, multiplying by conjugates is going to get you one of the Pythagoreans. They're kind of fun, aren't they? The identities? Yeah. They should be a little liberating because there's freedom in the identities. In a lot of math problems we feel restricted. There seems to be only one way to solve the problem, even though that's not true. But with identities, there's so many different paths you can take all the time. Which one?
Number 15 and 18 same.
I think number 15 is, 15 and 18 are the exact same, so you don't have to do 15 or 18, I guess. Don't do 15. I hope there's not any other duplicates. There is. 14 and 17, no, 14 and 16 are the same. Right? Somehow they got printed twice. Okay, so I've saved you two, or Eileen saved you 2 questions. I think that's it. Hopefully there's no other duplicates. Okay, anything else that you want to talk about? Okay, so I'll leave that with you, and then we'll, if you want more identity work, because you're kind of in the groove and you want to practice your skills some more, you can look in the book. There's few more questions. I'll be assigning them at some point, so I think they are on. So you can look on exercise 6.1, there's more identities there as well. It's asking you for number 1 to verify. Of course, we're not verifying with the graphing calculator, but, and they explain how to do that in the notes if you read it. You could verify these if you had a graphing calculator or a Desmos, right? And when you're verifying, you're just showing them, they actually end up being the same graph. Like when you entered this into with a graphing calculator, so you would enter in sine squared x minus tan x plus cos squared x. And if you enter this as a separate equation, cos x minus sine x over cos x, you're going to see that in either Desmos or graphing calculator, they're the same graph. I could show you one on Desmos today. So we're not going to do that because you don't have to do that. You have to do this with pen and paper. So verify for the given value and then prove it. Prove it for all values. Here they're just asking you to prove for all values. So you could take a look at number 1 and 2 as well if you finish the worksheet on page 202.